Open Academy.
So I go on next. I have another example here. A meter rule balances on a knife edge at the 55 centimeter mark when a mass of 40 grams is hung from the 95 cm mark. Find the mass of the rule. So I'm not giving a diagram here. I'm going to draw my diagram. I have my ruler. So I will draw now. So okay, my meter rule. Okay, so I'll take this up and I'll take this up. So I have managed to draw my meter rule. Now a meter rule is 100 cm long. The meter rule is 100 centimeter. So the midpoint of the meter rule is about let's say 50 centimeter. But this particular meter rule balances at on a knife edge. You see what a knife edge looks like here. This is a knife edge. The question says the knife edge is at the 55 centimeter mark. So it's not going to be at the midpoint, which is 50. It's going to be a little away from it. So I put my knife edge here. And when a mass of 40 grams is hung from the 95 centimeter mark, so it means that from this point to this point is 50. From this point to this point is 55. I think I should put that now. So I draw a line. I'll draw a line. No, I'll take that line again. Okay, so I took that a little further. Okay. So from this end to this end is 55 centimeter. This is the midpoint. This is the 50 meter mark of the meter rule. And the question says another mass, a mass, is hung at the 95 centimeter mark. So it means that from here to here is about 5 centimeter, because a meter rule is 100 centimeter. So if a mass grams is at this point 40 grams, is going to be 5 centimeter away from the other end. So if that's the case, that means this is the 55 mark, this is the 55 mark, this is the 95 mark. It means from here, from this point to this point is about 40 centimeter. 40 centimeter. So we have that. Now the weight of the meter rule will be concentrated at the 50 centimeter mark, will be at the middle. So we have another weight at this point, even though the question is silent about it. But since the question did not say, as in previous example, we saw a first example that says that the the weight of a bar is the bar is weightless. But in this particular example, it didn't say anything of such. So that means it's going to have a weight which is concentrated at the midpoint. Okay, so that's the weight, and I know that from here, from this end to this end is 50. From this end to this end is 50. From this end to here is 50, the midpoint. Now that means from here to the pivot here is going to be 5 centimeter, because the question says the meter rule is 55 balanced, is balanced at the 55 centimeter mark. So from it will be 5 centimeter away from the weight of the meter rule. I hope you got that. So taking moment about the pivot, we have this to be in the anti-clockwise direction, and we have this to be in the clockwise direction. So anti-clockwise moment is equals to the clockwise moment. So we have the anti-clockwise is W times 55 minus the 50 meter mark, that's 5, equals to the 40 clockwise, 40 times 40, the distance from this point to the pivot here. We are taking moment about the pivot, taking moment about the question says the knife edge. So this is the knife edge. Taking moment about the knife edge, I have the 40 grams times the distance 40 and the weight 55 minus the 50. The weight is on the 50 centimeter mark. So 55 minus 50 will give us 5. So W times 5, the anti-clockwise moment, equals to 40 times 40. So that's what I have here. I have 5W equals to 1600. So when I divide both sides, I will have 1600 divided by 5. 5 here 1, 5 here 3, I mean that 1, 5 in 10, 2, 5 in 0, 5 in 0 is 0. So our W is 320 grams, and that's same as having 0.32 kilogram. well, the question, the other mass was given in grams, but it's still okay this way. So that's the third example. We have the fourth example. A uniform beam 6.0 meter long, weighing 4 kg, rests on supports P and Q, placed left and right 1.0 meters from each end of the beam. Weight of mass 10 kg and 8 kg are placed near P and Q, respectively, one on each end of the beam. Calculate the reaction at P and Q. This particular question is similar to what we did earlier. If you haven't seen that, I would like you to check it. It's similar to similar to this, yeah, similar to this. So I will implore you, if you haven't seen it, to check it. Now let's get there. We have we have it there. We are not given any diagram, so we are going to draw the diagram. I'm going to draw a diagram. Look for my red pen. Can I find my red pen? Okay, let me manage this. Okay, so I'll draw my uniform beam, and the beam is 6 meters long. Let me draw it here this time. Okay. Okay, I managed to draw it. Okay, can I take the other one again? Make it a little perfect. Okay, let me manage it this way. So I have, my pen is very sensitive, so I bring this down. All right, so the beam is 6.0 meter long and is weighing 4 kilogram, resting on support P and Q. So the weight is about the middle. So I draw something like this down. That's the weight. Is most concentrated at the center. We have the value, which is 40 Newton. How did I come about 40 Newton? 4 kilogram is equals to 4 times 10, which is 40 Newton. So this is 4 kilogram. Then the question says there is 2 supports at P and Q, placed left and right at 1 meter from each end. So I can put something like this down. I can put this down. Sorry, it says it's support. So I draw something like this, like the support, and 1 meters from this point to this point. Then I'll come here. I have at 1 meter, I have another support, which is Q. This is P, and this is 1 meter. 1 meter from each end of the beam. And weight of mass 10 kilogram and 8 kilogram are placed near P and Q respectively. So 10 is near P and Q respectively, one on each end, need to pay attention to this. One on each end of the beam. So one on each end of the beam. So I put that here now on each end. Let me take that again. One on each, oh no, slanting. One on each end, okay. One on each end. So this will be 10 Newton. Sorry, 100 Newton. That's 10 kilogram. Remember what I did here. So then the other on this end now, I have it down. So that's 8 kilogram. That will be 80 Newton. That's 8 kilogram. Okay, so I have all the information on this beam now. Now the question is, calculate the reaction at P and Q. So I draw something that looks like this. So this is my reaction force. Let me call it X at P. Then on Q, I'll draw it up. Reaction force is always directed upwards, so that's why they are facing upwards. So just like I did in the first example in this topic, we have 4 forces here also. 4 forces here also. Oh, sorry, 5. 1, 2, 3, 4, 5. So I am finding X and Y, the reaction force. So just like I did in the first example, the total, let me start from here please. The total, my pen, I need color black. Is there color black there? Yeah. Okay, so total upward force or forces must be equals to the total downward forces. So we have 2 upward forces, that's X and Y. It must be equals to the downward forces, which is 100 plus 40 plus 80 Newton. So here we go, we have X plus Y, X plus Y equals to, this will give us 140, this will give us 220 Newton. So we keep that as equation 1. Then the second condition of equilibrium, total anticlockwise, oh sorry, that's not how to spell it, anticlockwise moment is equals to clockwise moment. So what do we have here? The let's take taking moment about, let me take moment about Q now. Taking moment, in the previous example, the first example, I took about P. Let me take about Q this time. Taking moment about Q. I can also take moment about this point. If I call this point R, I can take moment about this point. I can take moment about this end of the meter rule of the beam. I can also take moment about this. It's just like your point of reference. So I haven't fixed the distances here. From the beam is 6 meters, and from here to here is 1 meter, and from here to here is 1 meter, and this is the middle. So it means from this point to this point is 3 meters. 3 meters, half of 6. Now if I remove 1 from it, that means what is left is 2 meters. It means from this point to this point is 2 meters. Also this will also be 2. So we have 1 plus 2 plus 2 plus 1, which will give us the length of the beam, which is 6 meters. So I'll take moments now, but before I do that, I'm going to identify my clockwise and the anti-clockwise. So taking moment about Q, force 80 Newton will give me a clockwise moment. CW, taking moment about Q, Y will give me no turning effect. 40 Newton will give me an anti-clockwise moment, 100 will give me also anti-clockwise moment. X will give me a clockwise moment. Since it's facing upwards, it's going to turn this way, which is clockwise, to give me a clockwise moment. It turns this way. So we go now, taking moment about Q. Let's start with the 100. Since it's anti-clockwise, that's 100. We have 100 times the distance from here to here is 5 to Q. We are taking about Q. From this point to this point, Q is 5. So I put that here, close it, then plus the other anti-clockwise is 40, and the distance is 2. So I have 40 times 2, I close it, equals to, then the clockwise now, I have 80, and the distance is 1 to Q. That's 80 times 1 plus X times 2 plus 2, that's 4 to Q. So 4 or X, either way, X okay, times X. Okay, so we have 500 here. Yes, 500. We have 80 here. We have 80 also here, and we have 4x here, 4x. So what do we have next? We have 580 here. 580 equals to 80 plus 4x. So we have 580 minus 80 equals to 4x. I have 500 equals to 4x. So I divide both sides. I have x equals to I have x equals to 500 over 4, and that will give me 8, no, 9, no, that will give me okay, let me cancel out here. 2 here will be 2, 2 here will be 250. Yes, then 2 here will be 1, 2 here will be 125. Okay, so my x, I've been writing x this way, actually it's x this way, x in capital letter. So I changed that. X equals to 125 Newton. So that's x. That's the reaction force at P. Then using equation 1 here, we are going to get y. We have y equals to 220 minus x. So y equals to 220 minus 125. So y equals to 95 Newton. So that is the two reaction force at P and Q.